Testing 1, 2, 3. Pretty good. All right, switch slides. Back to first. All right. Are we set to go? All right. So I don't know how many of you saw my presentation last year, but the project is that I have a DeLorean, and it has I've replaced the instrument cluster with my own creation, out of fiberglass with a computer monitor in it, and I installed a computer in the car, and I'm collecting data off of the circuits of the car and rendering in my instrument cluster. And so a quick recap of last year is that there's an example of what my gauges look like, and actually I can animate that. Here we go. So there's the gauges in action. So the next thing that I wanted to do for it, actually, I have a lot of things I want to do for it next, but the one I decided to tackle next was to add mapping support. So you can see in the lower left corner there's a little exclamation point telling me that I don't have a GPS unit plugged in. If that was plugged in, it would tell me how many satellites I have, and it would turn green once it had a fix, and it would automatically update the clock of the computer to match, because you get that over a GPS. Anyway, so I wanted to enhance that and go ahead and I didn't necessarily want to create my own turn-by-turn navigation, because honestly I find those kind of annoying. So what I really wanted to do was just have some kind of mapping program that shows me the nearby roads, emphasizes the major ones, kind of hides the ones that don't lead anywhere, and emphasizes the possible ways that I could get to my destination, and then I'll figure it out from there. So let me turn that off. So the next thing is that because it's in a car, I want it to operate offline. I don't want to have a live internet connection to pull this stuff off of Google Maps or somebody like that. Not to mention, it would, if it's even feasible, you might just run over your data plan if you're driving around continuously with that enabled. So I wanted to have the map graphics merged with the rest of my dashboard. So the Google Maps app is great, except it's an app. It's a separate thing, and it's not merged with the graphics. So I wanted something that I could, like a library, that I could reach in and pull out images and things like that. I want to render them in real time. So I have a solid state drive in the car, and it's only 90 gig or something like that. So I was pretty sure that I wouldn't have enough room to pre-render every tile in the entire United States and compress that down and get it to fit on my solid state disk. And I could buy a bigger solid state disk, but they're expensive. So I looked around at some Perl modules. Most of the ones on CPAN only do forward geocoding, meaning that you tell it a place and it tells you the latitude and longitude. So I didn't find any of them where you give it the latitude and longitude and it tells you everything in the area. A lot of the other geocoding modules query web APIs, which is obviously not a thing I'm looking for really. And most of the code that I found that renders maps is usually sending it off to an external program which does the rendering for you. And unless you can keep that external program running and pipe back and forth, it's going to be a noticeable slowdown if you have to shell out to a different program to render your maps. So there again is the Google Maps app. I would have to install the Android stack on my car. Then I would have to find some way to capture its output, which could be done with a virtual X server or something like that. But it's cheesy. And then you don't have the ability to touch the screen. So without a touch screen, how do you even use Google Maps? You'd have to fake input. Anyway. So, and then Google Maps auto-updates all the time, and it's constantly breaking things. So if you tried doing custom stuff, it would probably not work for very long. So then there's the Google Maps API, which it requires an internet connection, unless I pre-cache all the tiles. But I looked into it, and the API is gives you a limited number of requests per month. They don't let you just fetch their entire database through their API. And there's still probably a storage problem because they give you a lot of data. So then there's a Tiger database that the USA Census Bureau provides. As I was reading around on the forums, people were like, the notoriously inaccurate Tiger data. And I was like, well, okay, maybe I'll try my chances with OpenStreetMaps. So Tiger might be a valid option. I didn't really investigate them very thoroughly. So OpenStreetMaps, I didn't really know much about it when I started. It's a collaborative effort like Wikipedia. So you log into their site, you get an account, and then you open up their web-based editor, and you can start editing maps. So if we jump over to Firefox here, yeah, there you go. So this is OpenStreetMaps. They've got where is it? Okay, so the other thing is that the Wi-Fi keeps cutting out, which is exactly why you don't want to have a web-based service when you're trying to drive around in your car. I found that loading example.com gets the Wi-Fi to work again. So there it goes. Anyway, so they've got lots of layers. They've got lots of additional information. You can turn stuff on and off. You can go to the, I'm logged in. Well.
I think it just says zoom in to edit.
Oh, thanks. Forgot about that. So you could just jump down into the middle of New York and then click the edit button. And you can just grab a street. You could delete the intersection, move the intersection, and a whole bunch of other options. They have the satellite imagery to help you line up your roads and stuff, and it's a really nice project. So I was kind of surprised that I had never heard much about it before. But yeah, so it's a collaborative effort like Wikipedia. You can just log in if your street isn't quite lined up right, or if somebody forgot that the road that you're on and thought it was a driveway or something, you can correct that and make updates. But for the most part, everything I've looked at is about right. So it's they've already done most of the editing, and it's kind of ready for use as is. So I was pretty happy with that. So back to slides. The data is freely available. There's a company kind of sponsoring this thing, and they provide services, with the data so that you can, they help you do things with it. But they provide free downloads, and you can go and download just gigabytes and gigabytes and gigabytes of, data. So I think it's 8 gigabytes for the entire U.S. But they have the entire world mapped pretty much. Well, of course, I have no idea how well they're doing in Africa or anything, but they do Europe and the USA pretty well. So the way people are usually working with the OpenStreetMap data is they load it into Postgres, and they use a PostGIS extension to Postgres to be able to efficiently search in 2 dimensions. The problem I ran into is that Postgres can't run on a read-only file system. Just flat out, we don't support that, you can't. So if I wanted to do, the car has a read-only file system so that I never have to worry about losing power and having things get corrupted. So if I wanted to use this in the car, I would have to come up with something like the LVM, virtual volume and, or an overlay or something like that so that Postgres could think that it was writing to the file when it wasn't. But the other thing is that the database is huge. So it's not just Postgres, it's Postgres with tens of gigabytes of database, which is going to also consume some of your memory resources, which I don't have a whole lot of in the first place in there. So I didn't really want to run Postgres, so I looked at some other options. I wanted to maybe do a static key value database. So the idea there is that I kind of they have fancy algorithms for sorting things and spatially sorting things, but I was like, for a map, it's kind of 2-dimensional, and you kind of only care about certain size blocks because as you know, for navigation software, you're going to zoom into a certain level, and you don't really need to see any farther than that. And things are pretty evenly distributed. You know, there's not like 20,000 nodes all in the same square mile. You know, they're spread out across the map pretty well. So I was like, well, I'll just create these tiles, and then take the roads that fit onto those tiles, and list them in kind of my own index in a key value database. And I decided that since there wasn't already a CPAN module for reverse geocoding, that maybe I would create one. So I tried Perl's DBM on a tied hash, and it immediately ran into the size limitations. And then I looked at some of the other, because you can only compile one of them into Perl at a time or something like that. So that, they have the Berkeley DB and the other options, but it didn't look like any of them were going to be able to scale up to multiple gigabytes of data. So SQLite would do it, but SQLite isn't very fast when you're just using it as a key value store. And there's a lot of data in OpenStreetMaps. Oh, I forgot to mention the OpenStreetMap data. Part of the problem is that they've divided everything up into a node, which is the latitude, longitude coordinate, and then there's a way, which is a series of nodes referenced through the schema, and then there's a relation, which is any number of ways and nodes with some additional tags attached to them, and they've represented everything on their entire map using that data layout. So what you end up with is like a single road that winds through a hill or something like that is going to have like 300 nodes along a 1 mile length, which every node gets its own ID in the database, its own row, its own timestamp, metadata, who edited it last, all that kind of stuff. And so there's lots and lots of data that they're giving you, and most of it I don't need. So one of the things I wanted to do with this module is to be able to trim down to only the nodes and ways that I care about. But I also wanted to turn them into more meaningful things. So like a way, is a series of nodes. It could be like the borders of a lake, or it could be the center of a road, or it could be the tiny little piece connecting the exit ramp connecting two roads, or it could be a bridge, or it could be a time zone barrier, or it could be the boundary of a state. So none of those things are very processable when all you've got is a string of points. You have to kind of know what it is and what its purpose is and whether it's supposed to be an area or a path. So with my module, I set out to kind of figure out what sensible objects needed to be made out of the OpenStreetMap data. So then, coming back to the key value database, how do you store all of this data? I had heard about LMDB, and it's the Lightning database system or module. I don't know what you call it. It's a library. So they use it in OpenLDAP. So it's the back end of OpenLDAP. It is only 32K of code, and what they basically do is they put a giant memory mapped tree that's backed by a file. But it also supports transactions and concurrent access. So they've kind of taken, you can't really get much faster than this, because what you're doing is you're taking some number of gigabytes of data, mapping it into your address space, and then just accessing the data structure. So you just jump in and start reading memory, and it's already loaded into your address space. You didn't have to copy it in and out of a buffer or anything like that. So it works really good. It's amazingly fast, and it supports everything's 64-bit, so it supports as much data as you want to put in it. And it has a CPAN module. So LMDB_file is the CPAN module for it, and the author wrote it in the style of the other DBM modules and stuff like that. So you can just kind of use it as a drop-in replacement, and you can tie it to a hash. You can just read and write keys from your hash, to infinity and beyond, and that was pretty cool. So I tried the tied hash, and then I did a little performance testing, and I found that it was a lot in a small benchmark example, it's a lot faster to just call methods on the object than it is to tie it to a hash and use hash access. So, whatever. So I also wanted to store Perl data in it, so I figured I would just use storable. I mean, I could also try JSON. I haven't done benchmark comparisons, but using storable and LMDB, I'm able to write 27,000 objects a second. So pretty good performance, and on a workstation, on my laptop. So reading goes a whole lot faster, although I don't have the benchmark numbers for you. And so the module I'm writing is geo : spatial db : and then it's got a bunch of stuff under it. This is probably, I don't know, arguably the most finished piece of the project that I've written so far. It's the wrapper around LMDB and storable, which I might spin this off into its own module. It's kind of handy. Anyway, so for the tiling, I decided that I was going to sort my objects based on their size. So like, part of the problem is that what happens if you have a feature that stretches across the entire state? Well, it's going to hit like thousands of tiles, across along the way. So rather than trying to either break up the object and store it in all those tiles, or store the entire object in each of those tiles, I decided I would have zoom levels. So there's like, there's whole degree, talking about degrees of latitude and longitude. There's like whole degree tiles at the top of my tree. And so what I do, when I do a lookup, I go to the top level and I say, what giant objects are there in this latitude and longitude? And then I zoom in to the next one, which is divided by 16, and I say, what objects are in this box? And then I zoom in again and I say, all right, what objects are in the tiny box? And when I get to the very bottom, then I just kind of scan through the IDs to collect all the remaining tiny objects. So that's how I build my set of what objects can be seen from this, or possibly seen from this narrow viewport. And then I load all of those objects and I render them in OpenGL, because that's what the rest of my dashboard's written in. The module I'm writing, spatial DB, I would like it to be used for more things than just OpenGL. But I have one use case. So if anybody else has other use cases that they would like to see made, possible with this module, I am very open to suggestions. The module is not finished. I thought it would be by the conference. There's a lot of crazy things going on in OpenStreetMaps that still needs, hammered out and ironed out. So if anybody, which if you're here, maybe you are, is interested in having a reverse geocoding module, talk to me. I'd like to collect some ideas and collect, what people can, contributions are welcome. All right, so, yeah, all right. So now we're down to the demo, which I was up late last night working on. So this is, I loaded the entire upper, they give you the data dumps in large chunks. So one of the chunks was the upper East Coast. So it's kind of like New York and up and west as far as Pennsylvania. And you can download these off of their website. And it was about 1.1 gig compressed XML, and it expanded to about 20 gig of LMDB storable data. Because I do a two-step process. One is I import all of the XML nodes to where I have them, quick access to them, and I can random access across and cross-reference things. And then the second step is I write out a second Lightning database file that has just the pieces of information I want and indexed by the tile that they fall into. So what we're seeing here is I started us at New York, and we're kind of like coasting southeast. So we'll eventually, cross Long Island here. And I've zoomed out farther than what you would see in the car so that you can actually see where the tiles are created and destroyed. And I have a debug mode here that I almost didn't get finished in time, but luckily I did. So now you can see where I requested the big rectangle, and then it's loading up all of the small rectangles, and for each one of those, it goes out to the database, pulls in the relevant objects, does a bunch of 3D math to calculate the vertices and stuff like that, and then plots the lines in OpenGL, and then compiles it into a display list so that you can tell OpenGL, redo that thing without going back through all of the process of describing the lines. or polygons in this case, because each one of these is actually a rendered, textured polygon. There's a lot of them. So also, the tiling that I'm using is just based on like fractions of a degree. So I start at whole degree, and then I do quarters of a degree in both directions, and then quarters of that in both directions. There are probably smarter tiling algorithms, and if anybody knows of some of those and thinks that they would make a good fit for the module, then maybe that's another cool thing to add. As I was testing the way I'm putting this into OpenGL is that is actually as 3D coordinates. I spent, because as latitude and longitude climb vertically, they get a little skewed. It's no longer a square, and so I was trying to apply corrections to kind of take a square and make it not square and fiddle around with that. So instead of that, I finally, I spent a bunch of work on that too. I finally found that you can, I just decided to, the math trig package has a spherical to Cartesian function. And so I take the latitude and longitude and I plug them into spherical to Cartesian and get a 3-dimensional point on a unit circle. And then I just render it in OpenGL after setting up the right viewport angles. So if we play with the code here a second, I think I'm about out of time. Was that what the? Yeah, out of time. All right, well, this is pretty quick. If we zoom out, that's zooming in. There's a higher up view where I'm only loading a limited number of tiles, because of course you can't load too many onto the screen at once. So there's another 10-time zoom out. And there's another 10-time zoom out. And there's another 10-time zoom out. So there you have it. You can take OpenGL and just render it in 3D, and after setting up your camera, you get perfect perspective on the coordinates. So, and then in the car, as I'm driving along, I'm going to be rotating the camera to kind of follow the path that the user's taking, and it's just camera rotations from then. So it is not loaded into the dashboard. I can't show that off quite yet, but that's where I'm at. So. Future work is, did you notice how there was that little hiccup as it would load the new tiles? That's because I'm doing all of my 3D math in Perl right now. So if I move that to XS, I think the hiccup will go away, and it'll be 60 hertz or 60 frames per second smooth. And I would like to do better pre-processing of the data, like divide all the roads at the intersections and some better stuff like that, because OpenStreetMap doesn't always do that for you, and put things in clockwise order and other helpful stuff. And for the higher tile size, I can't zoom out right now. The tile sizes are kind of fixed. I would like to have a thing that reduces the number of vertices in a shape so that you can zoom out and still render it, and then you would just hide the lower tiles. So I would like that to be built into the Perl module, and isn't yet. So, well, there you go.